Imagine a spacecraft, sleek and shimmering in the void, slicing through the vastness of space with mathematical precision, carrying with it the hopes, dreams, and decades of engineering brilliance. Its destination is Mars, the red planet, a distant and mysterious world that has captivated human imagination for centuries. As it nears its final approach, everything must go flawlessly. But in the cold silence of space, there's no room for error. One miscalculation, one failed sensor, one malfunctioning thruster, and that multi-billion-dollar marvel becomes a flaming wreck streaking across a Martian sky, vanishing into a dusty, lifeless terrain with a haunting finality. When a spacecraft crashes on Mars, it's not just metal and fuel meeting dirt. It's years of planning, engineering, and scientific ambition obliterated in seconds. There are no recovery teams standing by, no emergency shuttles racing to the rescue. A crash on Mars means instant, irreversible loss. And the consequences ripple far beyond the impact crater. The destruction can jeopardize future missions, contaminate pristine alien environments, damage critical infrastructure, and potentially erase data that was meant to unlock secrets billions of years old. This is the grim reality behind our pursuit of interplanetary exploration. When we reach for the stars, we also risk crashing into them. Mars is not a forgiving world. Its beauty is deceptive, a haunting landscape of crimson plains, towering volcanoes, and canyons that stretch beyond the horizon. But beneath its quiet majesty lies a realm of hazards. The atmosphere, while present, is thin and fragile, barely 1% as dense as Earth's, composed mostly of carbon dioxide. It offers no cushion for landing, no breathable air, no reliable resistance for slowing down a falling object. A spacecraft must perform a delicate ballet of precision maneuvers to survive entry. Too shallow, and it skips off the atmosphere like a stone on water. Too steep, and it slams into the surface like a meteor. There's no GPS on Mars, no real-time corrections from a control tower. Communications from Earth take anywhere from 5 to 20 minutes to arrive. That means every landing is essentially autonomous. The vehicle must think for itself, analyze terrain, fire retrothrusters, deploy parachutes, navigate dust storms, all while traveling at supersonic speeds. There's no room for second chances. If the software hesitates, if the sensors are misaligned, or if the terrain is rougher than expected, it's game over. The descent becomes a death spiral, and the final moments are nothing but a roaring blur of smoke, fire, and silence. And what follows is even more unsettling. A spacecraft crash on Mars doesn't just leave a smoking hole in the ground. It litters the landscape with debris, twisted metal, shattered components, hazardous materials, and radioactive isotopes. The wreckage becomes part of the Martian environment, a permanent scar on an otherwise untouched alien world. Each fragment can pose a danger to future missions, especially those attempting to land nearby. A single piece of jagged wreckage could compromise a rover's wheels or puncture a habitat. Even more concerning is the potential for biological contamination. Despite rigorous sterilization protocols, spacecraft still carry trace amounts of Earth bacteria. In the event of a crash, those microbes could be scattered across the surface, threatening to interfere with the very science we came to conduct, searching for life. Imagine a future mission landing just a few miles from a previous crash. Scientists drill into the soil, hoping to find native Martian microbes, only to later discover the samples were contaminated with Earth-based life forms from a shattered probe years earlier. The data becomes compromised, the findings tainted, and decades of work invalidated in a single oversight. These are not hypothetical risks. They're real concerns that planetary protection agencies grapple with every time we send a spacecraft to Mars. But the devastation doesn't end there. Crashing into Mars also means losing critical equipment, sometimes irretrievably. Sophisticated instruments, high-resolution cameras, data servers, scientific payloads, millions of dollars in precision hardware are instantly vaporized. More than the cost, it's the loss of knowledge that stings. Some of these instruments are designed to study things we've never seen before. Ancient sediment, subsurface ice, traces of methane. When those tools are destroyed, the science dies with them. And worse still, it's not always clear what went wrong. Mars is too far to send a repair team or a black box retrieval crew. Investigating a crash can take years of speculation, simulations, and forensic analysis based on limited telemetry. Sometimes we never get a clear answer. The mystery lingers and the lessons remain partially learned. Reaching the crash site is an ordeal of its own. The Martian surface is treacherous. There are no roads, no infrastructure, no guarantee of safe passage. Getting a rover to a crash site could take months, assuming it's even within range. And if the terrain is too rocky or the wreckage is buried under layers of dust, the truth might remain hidden forever. There are pieces of human technology sitting silently on Mars right now, mute witnesses to catastrophic failure, unreachable and unreadable. The emotional toll is hard to overstate. Behind every spacecraft is a team, a community of scientists, engineers, dreamers, who devoted their lives to a singular mission. When that mission crashes, it's not just a technical failure. It's personal. Careers are upended, funding is jeopardized, and the public's trust in space programs is shaken. The world watches in real time as billions of dollars erupt into a brief, blazing streak across the Martian sky. And for many it's easy to ask, was it worth it? But in truth, every crash is a painful but necessary step forward. It may sound strange, even cruel, but space exploration is built on failure. It has to be. Each mistake teaches us something vital. Every crash reveals flaws we couldn't have foreseen on Earth. It's how we build better landing systems, design smarter AI, and write more resilient code. The path to the stars isn't paved in perfection. It's carved out by trial and error, by grit and determination, by the willingness to risk everything for a sliver of progress. And when you think about it, crashing on Mars is an achievement in itself. It means we made it. We crossed the 300 million kilometer gulf between worlds and hit our target, even if the landing was catastrophic. That level of precision is astounding. In the early days of spaceflight, a failed landing meant missing the planet entirely. Today we can crash on Mars with style. And with each crash we get closer to sticking the landing. The next time a spacecraft crashes on Mars, the world will grieve. Headlines will call it a failure. Critics will demand accountability. But quietly, behind the scenes, teams of engineers will begin poring over data, piecing together the final moments, decoding the silence. And somewhere, in a lab or a classroom, a young mind will watch that crash, not as an end but as a challenge. A puzzle to solve, a wrong to right, a step in a much longer journey. Because the dream of Mars isn't just about the perfect landing. It's about enduring the setbacks, surviving the heartbreak, and pressing forward anyway. It's about understanding that failure on another planet is still progress for humanity. That every crater we make on Mars brings us closer to one day calling it home. And that in the harsh, unyielding silence of a Martian crash, there is still a message: keep going. Somewhere beneath the Martian sky, buried under windswept dust and alien silence, lies the twisted wreckage of a dream. But even in failure it tells a story. A story of daring, precision, and the relentless will to explore. Because a crash on Mars is not just a tragic end, it's a beginning, a warning, a lesson, and, most importantly, a test of how we choose to respond. The aftermath of a spacecraft crash ripples through the aerospace community like shockwaves through Martian soil. Engineers back on Earth scramble to analyze the last packets of telemetry, searching for anything, any anomaly, spike, or delay that might offer a clue. Timestamps are scrutinized, flight software dissected, simulations run endlessly in an attempt to replicate the final descent. Did a thruster misfire? Did the radar altimeter lose signal? Was the terrain simply too rugged to land safely? These are not abstract questions. They're the difference between triumph and catastrophe on the next mission. And with each answer comes the promise of resilience. Spaceflight demands perfection, but it rewards persistence more. Yet, the cost of failure can extend far beyond the loss of a single mission. Crashing on Mars casts a long shadow over future endeavors. Political leaders may become more reluctant to fund ambitious programs. Public support can waver when fiery explosions replace triumphant landings. Private investors, watching billions reduced to ash on a distant world, might hesitate to bankroll the next launch. And space agencies, already balancing on tight budgets and immense expectations, may be forced to scale back or delay future plans. One crash becomes a crater not just on Mars, but on humanity's timeline for reaching it. But the stakes aren't just financial, they're strategic. As space becomes the new domain for geopolitical influence, nations closely monitor one another's progress, or setbacks. A failed landing on Mars could shift perceptions of technological superiority, embolden rivals, or cast doubt on a country's capability to lead in space exploration. When the entire world is watching, a single spacecraft crash can echo across continents. That's why preparation is everything. And increasingly, it's not just about building stronger landers or more accurate navigation systems. It's about understanding Mars itself. Because part of the challenge isn't us. It's the planet. Mars is a hostile alien world that seems to conspire against our efforts. Dust storms can obscure terrain, choke solar panels, and interfere with sensors. The planet's gravity, just 38% that of Earth's, demands a delicate balance between deceleration and thrust. Its jagged landscape, dotted with ancient impact craters and sharp ridges, is a minefield for even the most advanced descent systems. And then there's the thin atmosphere, a cruel paradox, too thick to ignore, too thin to rely on. To land safely on Mars, you must overcome all of it. But even then, success is never guaranteed. Consider the entry, descent, and landing phase, what NASA famously calls 7 minutes of terror. During this time, a spacecraft must slow from over 12,000 miles per hour to zero, with no live assistance from Earth. It must survive searing heat, deploy parachutes, activate radar systems, ignite retro rockets, and execute a perfect landing, all while flying blind. If anything deviates from the plan, even by a few milliseconds, the result is a billion-dollar crater. Yet the pursuit continues. And as we push forward, we develop new tools to understand and respond to crashes. Mars orbiters are equipped with high-resolution cameras capable of imaging crash sites from space. In recent years, we've spotted the remains of lost missions, parachutes tangled in dust, impact scars marking the final point of contact, debris scattered across hundreds of meters. These visuals, haunting yet invaluable, allow us to investigate remotely. They offer closure to missions that might otherwise be forgotten. They help reconstruct the chain of failure. And sometimes they reveal glimmers of unexpected survival, hardware that withstood the impact, software that kept logging data until the end. But these efforts raise an even deeper question. What happens when humans are on board? It's one thing to lose a robot. It's another to lose lives. As we prepare for crewed missions to Mars, the risk calculus becomes exponentially more severe. A crash in that scenario isn't just a technical problem, it's a human tragedy, a psychological earthquake, a moment that could halt interplanetary travel for decades. Every rover crash, every failed probe, every botched landing teaches us not only how to build better systems, but how to safeguard the precious human lives that will one day ride inside them. The stakes have never been higher. That's why crash investigations must be exhaustive. We must understand not just how a failure happened but why it was even possible. Is it a flaw in the engineering culture? A failure to simulate enough variables? A lapse in communication between teams? Or perhaps an overlooked assumption that turned deadly in Martian conditions? These questions aren't merely academic. They shape the very foundation of future missions. If Mars is to become a destination for humans, we must treat every robotic crash as a rehearsal for survival. And yet, for all the destruction a crash brings, there is something beautiful about what follows. Teams regroup. Agencies revise their strategies. Engineers refine their models. New protocols are born. New technologies emerge. Smarter parachutes, more autonomous navigation systems, reinforced landing struts. In failure there is momentum. Because the desire to reach Mars doesn't die in a crater. It's reignited. Take, for example, the evolution of planetary landing systems. Earlier missions relied on basic parachutes and airbag cushions. Later ones incorporated precision radar and hazard avoidance algorithms. Now we're developing terrain relative navigation, where a lander compares onboard images to orbital maps in real time, adjusting its descent on the fly. Future systems may even include drone scouts, capable of assessing landing zones moments before touchdown. Every improvement is born from failure. Every advance is paid for in lessons written in Martian dust. And we must also consider the broader philosophical implications. Crashing on Mars forces us to confront the limits of our reach. It reminds us that space is not ours for the taking. It must be earned. The red planet doesn't roll out a welcome mat. It challenges us at every step. But perhaps that's why we go. Because the struggle itself is what elevates us. In confronting a world so unforgiving, we discover not just the boundaries of technology, but the depth of our determination. There's also a deeper planetary concern that extends beyond technology and science. Planetary protection. If we contaminate Mars with terrestrial microbes, especially in the aftermath of a crash, we risk irreversibly altering its ecosystem before we even understand it. That's why every mission undergoes rigorous sterilization. But in the event of a crash, containment is impossible. Biological contamination could spread unknowingly, seeding regions of Mars with Earth-origin life and masking the evidence of native organisms. The search for life beyond Earth becomes infinitely harder when we muddy the waters ourselves. That's not just a scientific failure. It's an ethical one. Yet still we press on. Because the idea of walking on Mars, of touching alien soil, of hearing the wind in an unearthly sky, it's too powerful to abandon. Crashes may slow us, may humble us, but they will never stop us. They simply demand more of us. More caution, more creativity, more courage. Every failed landing is a reminder that space is not a playground, it is a proving ground. And we are still learning how to earn our place there. In time, we will look back on these crashes not with despair, but with clarity. They will be chapters in a much larger story, of risk, discovery, and humanity's stubborn refusal to turn back. The wreckage will become monuments to resilience. The craters, milestones on a journey defined not by the absence of failure, but by the refusal to let failure define us. And one day, when the first human foot touches Martian soil, it will not be a step into the unknown. It will be the culmination of every mission that fell short, every signal that went dark, every landing that ended in flames. It will be a step taken with the weight of history beneath it, and the light of possibility ahead. So the next time a spacecraft crashes on Mars, don't look away. Don't call it the end. Look closer. In the dust and debris, in the silence and sorrow, you'll find something enduring. Something quietly defiant. The unbroken spirit of exploration. The belief that no matter how many times we fall from the sky, we will always rise again.